least I caught it early this time. So we plug in the 0 for the y. So in this case, I have 5x equals -7 divided by the 5. So x equals -7. So when we go to Alex, we had -7/6 for the y and -7/5 for the x. So you type them in as the fractions. We hit check, and we get this one right. So if you typed it in as decimals, these two both would have worked because they do. Well, the 6 might not end. No, the 6 continues. The 5th one would have worked, but the 6th one wouldn't because you would have had a round. So, and they don't like the rounding in these situations. If it ends purposely, you can put it in. That's fine. Like the -7/5 would have been -1.4, and if you put that in, it would have accepted that. In other cases, it would. All right. And this is basically how your tests are going to be too. It's like I'm going to pull problems directly from the assignment, so they'll look very similar to what you're going to see in the assignments. All right. Nice thing about Alex is Alex doesn't care which format you put the lines in. So you do not always have to get your things in the slope-intercept form unless it states that. Okay, so remember, for equations of lines, you have 3 different types of equations for lines. You do have your slope-intercept, which is your y equals mx plus b, which you see quite often and use a lot. We do have the ax. This is just not working well today. by equals c. That's the standard form, used not very often. One of the best formats for a lot of these is the point slope form, which we don't use very often, but it means you do not have to actually solve for y. So that's the y minus y1 equals m times x minus x1. And a problem like this one, where they give you 2 points that are not the y-intercept, that way is actually a really nice way to use. So for this problem, we just need to find our slope for those 2 points. What is the equation for slope? Yes. Yes. Now, it doesn't matter which order you put the y's and the x's, as long as you do them the same and as long as the y's are on top. So it doesn't make a difference which point you put first, in essence. So in this case, we're going to do, it doesn't make much difference. I'll do it the y2. So we have -1 minus -6 over -5 minus 5. Do make sure you keep your signs. That's very, very important when you're doing these. It's very easy to screw up your signs in this. We have 2 negative signs right here next to each other. So we're going to make that a plus. So we get -1 plus 6, which is 5. -5 minus 5, which is -10. So my slope is -1/2. Sorry. All right. So now when we're putting this in, you can use either point you want for the y1 and the x1. It doesn't make a difference. So we have y, I use the first one. So y plus 6 equals -1/2, and then x minus 5. Hold on 1 second. Yes. It should be in On the key rack, it should be the last one. It should be with the little spoon on it. Yeah. No, it's in the house. Okay. Sorry. Father came over to my house, needs to unlock these. All right, so we're gonna put this in the calcs now. So we have 5 plus 6 equals -1/2. And then x minus 5. Don't forget your parentheses around that. That does matter. You also do not need to use these. If you just do the slash key, it'll work fine. It would have used it. You could have put that. You could have done it as the y slope-intercept form, or you could have used the other point. Any of those would have come up with the correct answer in there. Sometimes it'll tell you that there was an alternative answer. It'll show it to you. Sometimes it doesn't. Any questions on those? A lot of people did get these. It was about 50-50 on these couple topics, but they're just one of those ones that are important, so I figured I'd go over them quickly. The parallel and perpendicular lines ones was not that well done. So, all right. And of course, the word problems are never the best ones that are on topic. So let's look at a couple of the word problems. Everybody loves word problems, right?
No.
Except everybody always wants to know when we're going to use this. It's the number one question everybody asks. When am I ever going to use this? It was funny. So when I'm writing the Calc 1 and Calc 2 books, and one of the things that I put in was that every single lesson that is done, they have to put an application problem. Now, you think as math teachers, we'd be good at coming up with word problems. They're having the hardest time coming up with application problems for these topics. I'm like, but we keep saying we use this. All right, so in this one, they want us to come up with an equation. When you're looking at most of these equations, looking at it in slope-intercept form is useful. So we're really looking for what's the change and what's the starting value. So in this problem, she has a starting salary of $2,500 and makes $120 for every copy. Keyword is for every. That's the change. So my slope is 120. My starting point, her base salary, or my B, is 2,500. So when we look at it now, we have to figure out what Y and X is. In this problem, they say her total pay, so total is typically your Y value. So we're going to make Y equal P, and that means X equals N, the number of books she sold. So my equation is P equals 120N plus 2,500. That's the equation. Why do these, like the word problems, yes, not every one of them is going to be realistic. Like some of the word problems that we have in our things are using like literally high-end physics concepts that you're never going to do. But understanding how to look at a situation and pull information out of it, that's important. That's one of the reasons why we really typically use word problems, is getting you that concept of being able to pull information out and saying, okay, now I've got this information, what do I need to do with it? Okay, that's really the key pieces of mathematics. And now in this case, they want us to, she sells 29 copies, so we're just going to change N to 29. In this case, I'm just going to use Desmos because I don't feel like doing this out in my head.
Like half the issue with word problems is actually finding out what the problem is.
Yes, and that's actually the most important part of why we do them, is like, because if you think about it, very rarely do you ever do a slope-intercept problem in real life. Okay, you're almost never going to do something like have a problem Y equals 120x plus 2,500. You're never going to see that in life. However, you very well could one day go, all right, I have $5,000 in the bank. I really want to go on a trip. I need $7,500. How much do I need to put away each week? That's this. That's literally this. That's something that you might do. So it's how would you then take that and solve that? It's like, okay, well, I got to take away, so I need $2,500. I got a year, so it's $50 a week. Like that's doing this, but you don't think about it that way. So it's learning how to take that and break it apart. That's important. So that's why we do stuff like this that annoy you, but there's a real rationale behind it. All right, so in this case, plug this into Desmos and we get 5980. So let's go throw this back over here into Alex. When you're doing these, the biggest part and the most annoying thing on this is make sure to use the variables the way they told you to. If they're capitalized, make sure they're capitalized. Don't put Y's and X's, otherwise it'll mark it wrong. So P equals 120 N plus 500. And then, yes. Yes, you do need the P equals in this case. What was it, 5980? So 5980. You don't need to put the comma between for thousands and stuff like that, but you definitely do need the P equals. All right, let's try another one of these. I'm gonna have you guys do one. All right, try this one. Hold on one second. All right, so what's my equation? Yeah, go ahead.
150 past 3,500.
Yep. Very good. And what's the total tonnage of sugar?
7,200.
Good. Okay. All right, let's get to a harder word problem. Oh, good. They're giving the cookie one. As horrible as it sounds, this is the hardest one in this topic because it's opposite of the way that you would think about it, which is actually a really good thing that they gave this one, not the other problems that are a normal problem. So we're going to. That's the problem. I'm going to show you in a second. No, why is my? Because it's so most of the problems that you're going to see, the slope's a whole number. In this problem, the slope's a fraction. All right. So a cookie company uses 1 cup of sugar for every 25 cookies made. So S is the number of cups of sugar used, and M represents the number of cookies made. So when we're looking at this problem, you'll notice, actually, I'll share this over here. They tell you what X and Y is based on the graph. So X is N and S is Y. So when you're looking at your slope, which goes on top, X or Y? The Y. So in this case, Y is sugar. It's 1 cup of sugar. So Y is 1 and X is 25. So it's 1 over 25, not 25, which is what most people try to put. Okay. So you have to look at how they set the X and the Y, because that would change that respect. The goal in this problem is to figure out the number of cookies that are made and how much sugar you use. So they want the Y, which is going to be your equals, is how much sugar is used, because that's what you need to know. And you're going to figure out, okay, I want to make this many cookies. So when you're setting this up, X is N and Y is sugar. So the sugar equals 1 cup for every 25 cookies times N. And if you have if you want to make no cookies, how much sugar do you need? None. So there's the y-intercept of the B is 0. You start off with nothing. Okay. So that's the equation. Yes.
What if you kind of wrote it out as like N divided by N? I mean,
You switched it?
N divided by 25 equals S.
Oh, actually, that should work. That should work. I'll actually try that. That should work, because 1 times N is still N. So I'll actually type that in that way. So this one, because actually I've never actually tried that. Oh, no, you're fine. Oh, I forgot the graph. All right, so now when you're doing the graph, again, just use a couple points, type them in. So we're going to use 0, 0. Now, if I want to make, I'm not going to put in 1, because I'm not making 1 cookie. What's the first number that I'd want to use? 25 cookies. So I'm making 25 cookies, and how much sugar? 1. And then we can connect our dots. Yep, it takes it. And you could have also done the 1 over 25, and either one would have worked. Okay. Yeah, I'm glad, because normally these problems are not. That's the one that always trips everybody up. So it was good that one came up. So we'll try another one of these real quick. Yeah, like this one. She begins her trip with 16 gallons of car. Car uses 1 gallon for every 30 miles. How much gas does she have left in her tank? So try this one. This is another little tricky one. Keywords in this case is how much she has left in her tank. What's my slope for this one? It is going to be negative. because we're using gas, and it's 1/30. And then this one does have a starting value, right? And she's starting off with 16 gallons. All right, so this one gives you a graph and wants you to pull some information out of it. So we're measuring a distant planet's temperature. The graph shows the temperature in Celsius versus the height in kilometer above the planet's surface. So what's the temperature at the surface of the planet? Correct. So here, I can zoom in on the graph a little bit better. Why would somebody say 3? Right. And people would think, well, that's obviously the surface of the planet. Okay. When you're looking at your graphs, make sure you understand what the graph's talking about. Okay. So in this case, that's 45. So which one is correct? As the height increases, the temperature decreases, or as the height increases, the temperature increases? Correct. If you ever fly or have flown in a plane or fly in a plane, they typically have the entertainment systems, and they'll show you the map of where you are. And one of the things that shows you on it is the temperature outside, the air temperature. And when you're at cruising altitude, it's like negative 40, like actually, sorry, it was like negative 45 degrees Celsius. So it'd be like negative like 90 degrees Fahrenheit when you're at like 30,000 feet. So as you go up in the air, it gets colder. Huh? Yes, that is literally why mountains get snowy tops. And that's actually due to air pressure because the density of the air goes down. So as the height increases, the temperature decreases. How much is it decreasing? Yeah, it's 15 degrees Celsius per kilometer. Now, the way this question is worded, should I put negative 15 or positive 15? Positive. Because it says at what rate is the temperature decreasing? It's decreasing at a rate of 15 degrees Celsius, not decreasing at a rate of negative 15 degrees Celsius. So little things. Yes, that would be a double negative at that point. So that's really, it's like sometimes, and where people get confused with Alex and why I do it this way to teach these classes, because these are the topics. It's like those are the little things that will annoy the crap out of you about Alex. Because okay, slopes going down, negative 15 makes sense, but the way they worded the question, they don't want the negative one there. All right. All right. I literally can't zoom in anymore to get the actual wording. Sorry. So this one wants you to actually model a situation with a graph. So throughout the last month, the Walker family pool was only half full of water. 3 weeks ago, Miss Walker filled the pool up with water. Since then, the pool has gone back to half full due to a slow leak. So the question is which one of those graphs is correct? Yes, the third one, because it was level at half a thing. She filled it, and then it dropped back down to half. Next one. Sam is hiking towards his campsite at a constant pace. A few miles from the campsite, he sees a snake and turns and runs the other way. A minute later, he sits down to rest for a while. Yes.
The second one,
Why?
because, well, he was walking at a constant pace, got scared, which caused his speed to increase, and then he went and sat for a bit.
I think it's the third one
Why?
because the only one that indicates going a certain direction, then going the opposite, and then resting for a while.
Okay. Which one?
To expand on that, why, axis is, decrease the distance to the campsite, so as you get closer to it, it's going towards 0.
Okay.
And then he turns around, so it goes back up, and then it sits.
Okay. So one thing that you're going to recognize about me, and I don't want anybody to forget, I will ask why, even if you have the right answer. Okay. So don't ever assume when I ask the question why, you think you have the wrong answer. You guys did good today. Normally, as soon as I ask the question why, they'll go, okay, never mind. So yeah, if I ask why, I ask why no matter what. Yes. Oh no, you're fine. You did fine. No, you did fine. All right. So actually, you made a very important point, which is actually the one thing that most people get wrong about this problem, is that the y-axis is the distance to the campsite. He's not at the campsite. So if he's walking towards the campsite, his distance should be decreasing. So that will eliminate the first one and the last one immediately. Because those, he's starting at the campsite and he's walking away from it. This one would be true if this was the speed he was going at. So if that was talking about how fast he was going, yes, he's walking at a constant rate. So he's going to start running, that rate's going to increase. And then technically, if he was going to sit down, it would drop down to 0 at that point. But that one would normally be about speed more than distance. So yes, the one that works in this case is the third one. Okay. This topic, you will always have 2 of them. And one will typically screw you up like the distance to the campsite one. All right, let's try one more. Actually, you know what? Let's see what the next one is. I can't remember what 7 was. Oh, yeah, 7 goes to perpendicular and parallel. So let's do one more of these. Then we'll go to the parallel perpendicular lines. All right. Try these 2. Or at least try the first one, then I'll switch to the second one. All right, what's the first one? Yeah. Why?
The amount of calories is increasing for the 3 months, and then that levels off, and it increases again.
Okay. And that's actually the only one that's increasing. So I can't even go, well, do they start off eating nothing at 0? But they do. So that's the only one that actually increases. So that would be the only one that would work for that one. All right. The helicopter. Yes.
It would be the first one because, well, you're already at a high height. You're on the roof of the hospital, and after reaching your peak, it just flies at the same level, and then you have to land on the ground to pick up the patient.
Perfect.
You can't just fly in the air to pick them up.
Very good. Perfect. It's a way to think about that one. All right. So we got this. Now let's move on to some parallel perpendicular line stuff. All right, so parallel and perpendicular lines. What do we know about parallel and perpendicular lines? Yes. So parallel lines and slope is the same. Why?
Just, depend on the line.
Can somebody explain why parallel lines are the same based on slope? Yes.
They change at the same rate. Will never cross.
Very good. Okay. So sometimes, exactly, it's not that it was wrong. You explained parallel lines, correct. When we're looking at one of the most important concepts in the beginning of calculus is going to be slope, because differentiation is all actually looking at instantaneous slope on a object that changes. So understanding what slope means and being able to explain things with slope is very important. So what about perpendicular lines? Yes, back. Yeah, so perpendicular lines are the negative reciprocal. So how do perpendicular lines intersect? You can't explain this with slope, so yeah, go ahead.
They intersect at like a 90-degree angle,
Okay, so
or they create them.
yeah, they create the 90-degree angles. Okay, so we said that the slopes are going to be negative reciprocals. So that means if we're having two lines that are going to intersect at 90 degrees, one's basically got to be going up and one's got to be going down, right? So that's why one's going to be positive, one's got to be negative. All right, the reciprocal actually just makes the slope correct. All right, so in these three, so the first thing we have to figure out for these before we can even do anything is what? Yeah, we need to find our slopes. So line 2 is easy. I'll just do it right over here. Line 2 is easy because it's already done for me. That's negative 2/3. Line 3, I just have to do what? I just have to, divide by 3. So that one also comes out to be negative 2/3. Line 1, I got to do a little bit more work for, not a ton. So line 1, I got to solve for y. Seriously, computer.
Why is line 2 just 2/3?
It could be. It probably is. Yeah. And it's going to be negative 2/3 actually. For x. Yep. So it's also negative 2/3. So all these lines are? All these lines are parallel. Yay. Now, that can happen. It actually can happen that neither happens too. So don't always like. Sometimes people will second guess themselves, like they can't all be the same. Something's got to be wrong here. Don't do that. It can happen. I've actually seen it where all three were neither. So doesn't happen often, but I have seen it happen. I have a few other topics for parallel and perpendicular lines. So, all right. Find the slope of those three lines. Do that part first. Oh yeah, another thing you also should easily quickly recommend or realize, don't always assume that I'm right when I put something on the board. If you get something different, tell me, because a lot of times I'm doing this stuff literally in my head quickly, and it is really easy to screw up a negative sign or something when you're doing things in your head. So if you get something different, feel free to tell me. All right, if you got those three slopes, now we should be able to figure out parallel and perpendicular lines, right? So line 1 and line 2. They're neither. They are negative, but they are not reciprocals of each other. What?
I don't think I understand the parallel versus perpendicular kind of.
So parallel means that their slopes would be exactly the same. So if line 1 is 3/5, line 2 would have to be 3/5.
Oh.
Got it now?
I was confused. I was like, you're just taking one line and then
Yeah.
you realize it's line 1 and line 2.
That's okay.
Line 1 and line 3 considered perpendicular.
Yes, line 1 and line 3 would be perpendicular because they are negatives, they're opposites, and they are the reciprocal of each other. So those would be perpendicular. And then line 2 and line 3 are neither. Okay. How would you determine if something's a right triangle? They have to have a 90-degree angle, right? Which means two lines have to be perpendicular. So if I took those 3 points there, two of those lines should be perpendicular, correct? Okay. So when you're looking at this topic, I have to write. It's in essence exactly what we just did in the last topic. Just you have to do it a few more times. So for A, we'd have line PQ, because we don't know which one is going to be the corner. They don't tell you, like they don't put it on a graph and say, here's the points. So we have to figure out PQ, we have to figure out PR, and then we have to figure out QR. So you have to find the slope for all three lines. And then, as long as two of them are perpendicular, they would make a right angle, and we'd have a right triangle. Yes.
Did you graph those 2 points?
You could graph them, and that might be a quicker way to do it, just like to give an idea of what it is. So, what do we got? 2. So if we graph these three, this is what we would get. So if I had a guess, I would check -7.2, -3.10, that one, and then -7.2 and 0.2. Those two would probably be the two that I would check. But you can't always necessarily go by looks. So you can't assume that that's the right angle just by looking at the picture. You do still have to check them to verify it. So, but yeah, I'd say those would be the two that I would check. So if you want to use that to narrow your choices down, that's fine. I don't have a problem with that. So, all right. So is the first one a right triangle? Figure that part out. So I think we said, what was it? PQ and PR. So check those two. Those two are the ones that we said would work. I have to remember sometimes I switch on this screen, but I forget to hit share, so it doesn't switch on the screen you can see. Right. That was that one.
These ones, do you need to go through every single line?
No. That's what I said. Just the first two are the ones that we think would work.
Would any random two work?
No, because like if you had tried, so you really have to check to officially know for sure. You should all check all three lines. If you're going to graph it to try to visually identify which two you think are perpendicular, you can probably narrow it down to two. I did all three just because it was quick and easy to do the last one anyway. All right, so I got 2 for PQ. Did I do that one right? Because I got -8 over -4, which should be 2. And then for PR, I got -4, or actually +4 over -7. So -4/7. So those two are not perpendicular. Since I know those two are not perpendicular, I might want to check the last one just to make sure that it wasn't funky. The last one considered to be -4, so that's also not perpendicular. So in this case, it is not a right triangle. You should never, in this situation, unless they give you 2 points, it'll never be cannot determine because you'll always be able to determine a right triangle. Let's go back because I'm not going to do all 3. We're going to hit show explanation because I don't feel like doing them all out. So there's the graph of them. We got our 3 answers right. So that's not a right triangle. Second one actually wasn't a right triangle either. The third one was. What? The 2 of the 3 weren't?
First one wasn't, it literally looked like a right triangle.
Well, and it was like, it's actually even this one, like if you look at it, looks like a right triangle. That's why you'll never, and anytime if you like took the SATs or any standardized tests and stuff like that, they'll state in the pictures not drawn to scale because it could look like something, but it doesn't necessarily prove out to be that way. So actually, when we're drawing triangles, most math teachers will draw a right triangle purely because it's the simplest triangle to draw. Even if we don't want it to be a right triangle, it's easy to draw 2 straight lines. So it's actually really hard to draw an equilateral triangle. But that's where we're at. All right. Any other questions with parallel and perpendicular lines? There is a bunch of topics that come up with those. So, all right. Now we're going to move into some rational functions, radical functions, absolute value functions, and we'll look at some domain and range of these. First thing, though, is quite simple. We literally just want to evaluate them. So when you're looking at these, this first one, that's known as a radical function because it has a square root in it. So square roots, cube roots, fourth roots, anything with a root or a fractional exponent, because a fractional exponent is a root, is a radical function. The last one, h of x in this case, that's a rational function. Rational functions are fractions. The one in the middle is a what? Absolute value. What does absolute value do? It changes it to positive. It's telling you distance. Okay, absolute value is telling you distance from 0. So in essence, you will always get a positive number out of a absolute value function, unless there's a negative, something outside of the absolute value. All right. So the first one, they want to know f of 3. So what do I get? Yeah. Square root 17. So we're going to put in root 17. I don't think it'll take. Yeah. As most, you can type SQRT. It'll actually change it to a square root. Alex doesn't let you do that. So you have to hit the square root button. That's one of the downsides of using a calculator a lot of times, because if you do that, it will give it to you as a decimal and not as a root. So just keep that in mind. If you get a decimal out like that with a root, just plug the inside of it in, see what you get. In this case, they also ask you to simplify your answer. Root 17 does not simplify down, but if you got root 20, you would want to simplify that down. Does everybody remember how to simplify square roots?
Yeah. You find a root in a root. And
Would you like me to show you quickly?
Yeah, I have some idea. It's square root of 20. One, it'd be square root of 5 and square root of 4. And one of those numbers can be simplified.
Some are easy, some are not. It's okay. Hold on, let me get a number real quick. Because I don't want to do it. I want to do a more complicated one than the simple one. So. Let's do this one. If I'm going to pick one, I might as well pick a hard one. All right, so you probably, if at any time you did this, you probably did this in like the beginning of middle school. Like middle school teachers like to make mobiles for some strange reason, and they do factor trees as a mobile. We're basically going to do a factor tree. When you have a like simple square roots like 20, yeah, you'll probably be able to break those out. Okay, it's 4 times 5, so it's 2 square root of 5. That's simple. When you get some more complicated numbers, though, that you can't quickly figure out the pieces from it, factor trees work really, really well. 3528, it's even, right? Half the numbers in the world are even. So half the numbers you get, you're going to be able to divide by 2. So if it's an even number, divide it by 2 and start from there. Okay? So we're just going to take this and divide it by 2. 35.8 divided by 2. Now you get 1764. Hey, look, 1764 is also even. So divide it by 2 again. Hey, look, 882 is also 2. So let's divide it by 2 again. I'm just going to come over here. Oh, 441 is not even. So I can't divide by 2 anymore. And at that point, we know we're never going to be able to divide by 2 again. So you can eliminate worrying about 2. Does anybody remember the trick for 3? Add up all the numbers. If that can be divided by 3, your number can be divided by 3. So it's 4 plus 4 plus 1. 9 can be divided by 3. 441 can be divided by 3. So divide by 3. All right, so now we're at 147. Notice that the number gets smaller pretty quickly, and then we can start thinking about, again, let's add them up, see if it can be divided by 3. So 12 can be divided by 3. It's divided by 3 again. 49, what's 49? 7 and 7. Okay. This is a what? So now this works for any root. I'm doing a square root, but the same process will work for a cube root, fourth root, fifth root, 10th root, doesn't matter. The only thing that changes is the very next step. It's how many times you circle. So since this is a square root, I'm circling pairs of numbers. So I have a pair of 2s, a pair of 3s, and a pair of 7s. So on the outside, I have 2 times 3 times 7, and I have a 2 left over inside, and that's my answer. So this answer is 42 square root of 2. That'll work for every single root you will ever see. You can tell I taught high school for a long time. I have to teach all these tricks, otherwise the students have no clue what I'm talking about. So yeah, that'll work. If it was a cube root, you'd have done the same thing, except I would have circled groups of 3. So
any number, if you add it up and it equals
divisible by 3, you can divide by 3. So 2's even, that's fine. You'll never have to worry about like 4, 6, any other even number because you're going to divide by 2. Any numbers that add up to things, you get 3s. Any number that ends in a 5 or a 0 is 5. You'll never have to worry about 9 because you've already done it by 3. 7's a little funky, so yeah.
Pertaining to what this class can do, like after you're done with this, you jump to statistics.
Yeah. Yeah. You can actually take statistics now. You didn't need pre-calculus for statistics. You needed college algebra for statistics. Yeah. Mm-hmm. Statistics is not necessarily easier, though. I'll tell you that now. Statistics is different. It's different. But from here, you can go into calculus. You can basically pre-calculus opens up all the rest of the major math subjects. So you can take statistics. You can take calculus. Mostly, if you're going into any of the engineering fields or things like that, you're going to need Calc 1, probably Calc 2. Those things in there. So that'll open up those things. Pre-calculus is just your culmination of your algebra life, in essence. You'll never be looking for a job. Let me put it that way. There's so many positions out there for math teachers. I every single day I'm getting an email from a different district looking for a math teacher. So like they definitely have them. Yes. Oh, you're stretching. Okay. All right. G of X. They want G of negative 1/3. Yes. You want to know the trick to multiply whole numbers times fractions? Multiply times the top, divide by the bottom. Or if it's easier, reverse it. Divide by the bottom, then multiply by the top. So this case, what's 12 divided by 3? 4. If it was 2/3, 4 times 2 is 8. There's your answer. So just pick one, whichever one's easier to do off the start. Yeah.
So you don't have to do minus 12 and positive 15 and then break it into 2 different problems?
No, you cannot. So an absolute value, you have to do its inside first. Absolute value is just like parentheses. So you do inside and then you deal with the absolute value. So you don't break them up. Same thing with like the square root. You can't break that up into the square root of 2 plus the square root of 5x. You have to do what's inside of that first and then deal with the outside piece. Okay, good question though. So we got, what was it, negative 19? So the absolute value of negative 19 is positive 19. All right, now we got the rational function. Negative 2 is what they're plugging in.
You're right, bold, 19 and minus 4.
No, because it's absolute value. It's the answer is 19. You don't have both. You have, it's always positive. So, And -8 plus 6, 2, -8. They should have gotten -8 plus 6 is -2 on the top. And then -8 on the bottom. So -2 over -8 reduces to +1/4. This one didn't have a square, but do make sure you keep in mind your parentheses when you're plugging things in. If it was -2 squared, it'd be +4. So just keep that in mind when you're plugging things. If you typed it in a calculator as -2 squared, you'd get -4 as your answer, because it would assume the negative sign was not part of the 2. So little things to keep in mind when you're plugging things into calculators. All right, let's look at some domain and range. Alex does domain and range a few different ways. This is interval notation, but they'll also use like x is greater than, those things as well. So interval notation does get a lot more used when we're looking at it in terms of calculus, but they're all useful. All right, so a couple things for interval notation. Actually, let's do a few things with domain and range first. What's domain? Yes. So what is another way to state that?
X value.
X-axis, x-value, same thing. What's another way? It is your inputs. It is the things you're plugging in, because not necessarily always going to be x and y. All right. Depending on when we don't get into a pre-calculus, but you do later on polar and parametric equations, you do have different inputs. So your domain will change in those respects. So domain is your inputs, which is typically your x. So what's your range? Yes. Y is your outputs. Which is typically your y. All right. When you're looking at interval notation, the parenthesis is not included. Well, so parenthesis is an open circle, a bracket is a closed circle. So parenthesis means that point's not included in the domain. It could be parenthesis. It doesn't necessarily have to be parenthesis bracket. So you can interchange them, or you can just have the parentheses. The bracket means that point's included. Oh, thank you. I was. There we go. Now you can see everything I wrote. All right. So yeah, parenthesis is not included. It's typically an open circle. The bracket is included. It'll be typically a closed circle. So parenthesis means it's not included in the domain. So in this case, we have our graph. We're going to look at them with functions as well. But so what is my domain of this function? Yep, because I got a bracket there. So I got a bracket. And it's -3. And then I have an open circle at 3. So it's bracket -3, comma 3 parentheses. What's my range? Yep, bracket -5, 4. Yeah, it goes up to 4. Should I put a bracket or parenthesis at 4? A bracket. Even though there's no point there, it goes through that point. So it is included. This is not an endpoint. So I've got And when you type these in, you do not need to use their symbols for them. You can just type them on the computer. So they've got the bracket symbols and everything else here. You don't necessarily have to use those. You do have to use the union button. Don't just hit U. And they do have the infinity symbols. If it goes to infinity, you will never include infinity. So it's always parenthesis next to infinities. Okay. All right. So we're looking for domain of these. So what are my domain restrictions? Not necessarily in this problem, in general. What are the domain restrictions that you can have? So I can't have equal to 0. Was that the one you were going to say?
Zeros of a function, so.
All right. So it cannot, wait, hold on. What did you say now again? Yeah. Okay. Yeah. I can't divide by 0. So one domain restriction is cannot divide by 0. Okay. Which is different than the zeros of a function. That's why, like, I heard that piece and I'm like, those are two different things. So, because the zeros of the function can exist. That's actually on the top of 0. So no dividing by 0. What's another domain restriction? Yes. Okay. What's the restriction? Nope, I can have a square root in the denominator.
Can't be, there's like a certain thing where if the exponent is higher than the other exponent.
No, forget this problem. It's not necessarily related to this problem. Yeah, I think you were thinking about horizontal asymptotes. Yeah.
So for square roots, it can be like the number inside square root equals 0, but it can't take the lower.
Correct. Can't take the square root of a negative number. Otherwise, I get an imaginary number. So a domain restriction for that would be, it's actually for any even root. So even roots have to be greater than or equal to 0. There's one more that most people don't actually ever think about, but it's actually really, really important. Yes.
But any X input can have 2 Y inputs.
Then it wouldn't be a function. So it's actually, so we would eliminate it before we even got to the domain and range step at this point. But you're right. That actually does deal with functions. So yes, you can't have, it would fail the vertical line test in that situation. Yes. Holes in a graph just represent the domain restrictions. The one that most people don't remember or don't think about is a real life restriction. Can I have a negative volume? No. I have negative area. Can you walk negative feet? No. So there's, when you're looking at especially application style problems, those restrictions come into play and need to be looked at. So I call those real life restrictions. So it's one of those things that most people don't even think about, but they do come up. Because when we look at, once we take a problem, a word problem or something, we put it into an equation, we just look at the equation. But there's restrictions that that problem should have been built into. In this case, we're looking at number 1. We're looking at that denominator. So my denominator cannot equal 0. Now, we were talking, somebody mentioned asymptotes. There's different asymptotes. We can have vertical asymptotes or horizontal asymptotes. Your domain restrictions typically turn into vertical asymptotes. They also can turn into holes, depending on if the number would also work on the top as well. So in this case, we could have either one of those. I'll actually, in this one, we actually will have both. So I'll actually show you that. But my domain restrictions in this case, I just set the bottom. You can set it equal to 0 or not equal to 0, whichever way you want to look at it. Doesn't make a difference. So how would I solve this one? We could factor it. This one I actually don't have to factor necessarily, though, because it's just an x squared. I can literally solve it for x squared. You could factor it, though, if you wanted to. It's going to come out to be the same way. So if you factored it, you get, in this case, it's x plus 1, x minus 1. So I get x equals -1 and x equals or not equals to 1. If I was to solve it, which I'm actually going to do because I think this is actually one of those ones that's important to see, because a lot of people miss this. When you take the square root of a number, you have the plus or minus of it. Don't forget that, otherwise you will lose domain restrictions. So in this case, I have x equals -1 and x equals 1 would be my two domain restrictions. When we're going to write this in terms of a interval notation, which is what they want for this problem. They wanted my domain in terms of the intervals. So when we're writing this, they want my domain, not the restrictions. So the numbers that would work would be -infinity to -1. Notice how I put a parenthesis there, not a bracket, because -1 does not work. And -infinity, the infinities never have it. Then I would use a u. All the numbers between -1 and 1 would work, again, parentheses. And then I would have another u for 1 to infinity. And that would be my domain for this situation.
What's the range?
It's not asking for the range in this one. There's a reason why it's not asking for the range in this one. It's a little harder to figure out the range in this one.
Trying to figure it out, and all I'm getting to the mind.
It's actually -infinity to, well, it's -infinity to 0 and then 0 to infinity. The only number that doesn't work is 0. The 0 doesn't work on either the top or the bottom. If you were to graph this one, yes. Yeah. Yes, but that's not going to, you're going to eliminate a domain restriction in that situation. So that's actually exactly what I was just going to actually talk about in a sec right now. No, you're fine. You're a step ahead of me. So we're talking about asymptotes. If you were to graph this, this is what you'd get. And you might go, okay, my domain restriction's 1, which is true. A domain restriction is 1. That gives me my vertical asymptote. That's the one that would not have been factored out if I had factored out and reduced the problem, because I would have gotten 1 over x minus 1 that was left. But if we look at going, if we go right here, that point right there at -1 is also undefined. That is also another domain restriction. That is a hole. Desmos doesn't necessarily represent the hole on your graph. Okay. So for those ones, I know I mentioned, or somebody mentioned last class, well, my teacher just let me graph it and be able to figure things out. Sometimes it works really well. Sometimes it doesn't. All right. So you would have lost the domain restriction if you had if either cleaned it, simplified it first, or graphed it and just looked at the graph. So you do have to keep those things in mind. Okay, so when you're looking at these, you want to try to be as exact as possible and as full as possible. Sometimes solving them out is the best way to go about doing that. So yeah, this one has a hole and a vertical asymptote. All right, let's show you how to type this one in. So for this one, we have -infinity to -1, u, -1 to 1, and another u to infinity. Okay. What's the G? This one's actually pretty easy. So the only domain restriction is -6. The only domain restriction is -6. So I have negative infinity to -6. And then -6 to infinity. Okay. Couple more. We're almost there. Find me the domain of this one. All right. What would I do for this one? Actually, this one you would not want to set equal to 0. I'd want to set it equal to greater than or equal to 0. You want the inequality sign there. This one doesn't matter, but there are ones that do. So in this case, I would set this equal, and then we'll. So there we go. I know. So in this case, I get the 4x is greater than or equal to -36. So x is greater than or equal to -9. And it's fine. The reason why, like I said, in this case, it doesn't make a difference. So in this case, I would have the bracket at -9, and we're going to infinity. That would be my domain. If we said, let's do, if we had the square root of that. So now I do 25 minus the 5x is greater than or equal to 0. -25. And now this one, because I'm dividing by a negative, I have to switch that. Okay. If you had the equal sign there, odds are you'd forget to switch it and you'd have just assumed it was greater than and not less than. So in this situation, I would have had the negative infinity to 5, and that would have been my, when you're dividing or multiplying by a negative. So if you remember from the first class, I said you actually, typically I would move the negative one so you don't have to worry about that. The 5x would have gone over here, and I would have had 5 is greater than or equal to x, which then I would have had a right if x is less than 5. So that's why you have to switch it, because it would have switched if you did the other side. So just the little things to keep in mind. That's why, like, when I'm doing when it's not equal to, it's fine just putting the equal sign there because it's in essence the same thing. But for square roots and stuff like that, the inequalities, you typically want to put them there so you don't forget that step. So this one. All right. While this is one of those topics that most people hopefully should get correct, I would hope. However, there is a reason I chose to pick this up and put it in here, because one of the things that you start looking at more when you get into the calculus and stuff like that. Remember, the goal of this class is to prepare you for that one. So if I say, well, this is the stuff you're going to use in the next class, there's a reason for that. We typically are starting to look at where things increase or decrease based on a function and not a graph. So you're not necessarily going to see the graph. We want to figure out where these things are. So understanding the intervals and figuring out where they increase and decrease is actually very important. So, or where they stay constant. So this one's pretty simple and straightforward, and I hope everybody would get this one correct, but that's why I wanted to actually put it up here. Between A and B, is it increasing, decreasing, or constant? It is constant. Okay. B and C. C and D. D and E. Which one of those intervals has the greatest slope? Let's see.
A,
A to B. The slope for A to B is what? If it's constant, your slope is 0. I think it's actually B and C. B and C is slightly higher than D and E. Where's your negative slopes? C and D. Do I have any undefined slopes in this case? What would be an undefined slope if you were going to represent it? No, it's not on the graph. A undefined slope is a vertical line. So I used to tell my students it's like walking. Walking on the floor is really easy. It's the slope 0. Try walking up a wall. Can't do it. So that's why it's infinity or undefined.
It only works in cartoons.
Exactly. So, all right. All right. Go back onto. Let's try to see if it goes. Ooh. All right. We'll go back up because I want to do one more domain one. Find me the domain of this function. All right. What's the domain? It's less than 0. No. The -6 actually has nothing to do with the domain of this problem. Because the -6 is not underneath that square root.
it's not a real.
No, it is. It's just, it's the numbers that would work are going to be from negative infinity to 0. Any negative number would work because negative would make it positive, and then I could do the square root of it. The -6 in this situation is not part of the square root, so therefore we don't need to use that as part of the domain, because the domain is just what's underneath the root. Just like when we were looking at the rational function, I didn't care what the top was. I just looked at the bottom, because the bottom was the only part that actually mattered in that situation. So, and these problems, again, this is one of those ones, it was designed to be tricky just to be tricky, because they didn't extend that line over the -6. Okay, so just little things to keep in mind when you're looking at. We're just looking at underneath the roots there. That was a good next problem. All right, yes. Any other questions? Okay. Remember, Monday is Labor Day and there is no class if you have class on Mondays. This class isn't affected by it because it's Tuesday. But I figured I'd let you know because some people don't realize that. Have a wonderful weekend. I will see you on Tuesday.
All right. Bye.
Good night.
See you next week.
So what is the, my name is Michael.
Hi, nice to meet you. Oh, you're fine.